Members, let's continue with the network analysis. We have already seen two kinds of diagrams, activity on the node and activity on the arc, and they are below here shown. The first one is activity on the node. The node shows activities like A is the beginning activity, so is D. Now the arrows, like we have an arrow from A to C, shows you that work flows from A to C, and so A is a precedence of C, so is it a precedence of B, that work flows from A to B and C, or A, B and C actually use inputs from A. Now E gets its inputs from B, C, D, and so these are predecessors or precedences. And so that's how work flows, and it flows in paths. Like path is showing you the flow of work from start to end. Like ACE is a path, so is ABE, and then the other path is DE. The second diagram is activity on the arc, where the arc shows activity, but the nodes are just points, start and end points, and also shows the path as we have seen up. This is a structure of a node. The node has three parts: the upper part, the middle part, and the lower part. The upper part is showing us earliest start, then duration, then earliest finish. Then the middle part is the name of the activity. It could be maybe roofing, or it could be codenamed A or R or whatever. And then the last node, the lower part of the node shows you latest start, slack, and latest finish. Now, early start, early and late times. The first task is assumed start at time 0, and this is the earliest start. Now, earliest finish is earliest start plus duration. When you have an activity that starts at, say, 0, but takes 10 days, then the earliest finish will be 10 days. It will be the 10th day. Earliest start equals earliest finish of the task immediately before. If A precedes B and A ends after 6 days, then B must be starting as A ends D starts, so it starts after 6 days. Latest start is latest finish minus duration. Latest start is latest finish minus. If you get the last task, the end of the project, that task, its finish time is both the latest finish and the earliest finish and the latest finish, because it is the end activity and it shows you the project completion time. So that is the time when the project ends. And so the latest finish for it, rather the latest start for it, would be latest finish minus duration. However, latest finish equals latest start of the slack of the task immediately after. The slack value equals latest finish minus earliest finish, or latest start minus earliest start. You do this for all the tasks, and then you can show the slack time for each activity. Add the float time of the activities along the path to get the slack along that path. Identify the critical path. A sequence of connected activities running from start to end in a network is a path. Now the path with the longest duration is the network is the critical path. The pathway connecting all the nodes with slack 0 is the critical path. So the critical path has the longest duration and also has total slack equals 0. The networks have got advantages. E.g., each activity is a node, and so it is easy to construct a network. Easy to label with activity description, L start, L finish, and let start, let finish times, lead, lag, restraints, resources. Milestones can also be displayed as nodes, but they will have 0 duration. So networks are easy to show critical paths and near critical paths. And they expose activities that must be coordinated to avoid conflict. So use of these techniques forces managers to organize and quantify available information and to organize where additional information is needed. The technique of networks provides a graphic display of the project and its major activities. Networks identify activities that should be closely watched because of the potential that they have to delay a project. Other activities that have slack time and so can be delayed without affecting the project completion time. This raises the possibility of relocating resources to shorten the project. Now, but there are some disadvantages. The networks require a lot of precise data. Difficult to show time scale. In the Gantt chart, we saw how it is a timeline. Here, we can't expressly see that timeline. You can put the nodes on horizontal time scale or stretch the nodes, but again, this will confuse the presentation of the node data. The best method of establishing and calculating the network is in the hands of the competent scheduler, and these competent schedulers are scarce. So the method is used by most computer programs, and when done, it is presented like a bar chart anyway. Let's have this illustration where a researcher gives the following list of activities and the sequencing requirements along with expected time in weeks for the various activities related to completion of our research. Our research dissertation. Activities are A, B up to L. A and B are not preceded, but C is preceded by B, and D is preceded by C, and then A and D precede E, etc. So we are going to draw a network for this research project, clearly showing the earliest and latest possible start and finish times, to compute the float time for each activity and the minimum time to complete the project, to identify the critical path and explain why it is critical. So we can draw the network from the table, knowing the time and the precedence relationships. We know that A is not preceded, so is B. A is preceded, B is preceded, B precedes C, and C precedes. When you look at the activity A and B, they start at time 0. That's the earliest time. Earliest start is 0. Activity A starts at 0, then you add the duration, you get the earliest finish, which is 6. B starts from 0, you add 5, which is the duration, and it gives you the earliest finish. So, which is the earliest start for C, and C takes two weeks, and so that means it ends after the 7th week. So D starts at the 7th week, takes 2, ends after the 9th week. Now I want you to look closely at E. E is preceded by both A and D. You are wondering why the earliest start is 9 for E and not 6 when A ends. Remember, E needs inputs from A and D, i.e. E depends on prior completion of both A and D. You would have taken 6 as the earliest start, but remember, the other predecessor has not completed, and both must be complete. And so, E starts after D has completed, and that's 9. Then it ends at 11, and then 11 to 16. Again, I want you to look at I. I is preceded by F, and F is preceded by D. So D ends after 9 weeks. So that's when F starts, and it completes after 10. And then you are wondering why I does not start on 10th. But remember, I is started, or the starting of I depends on prior completion of both F and H. And so that's why we take the finish time for H. Members, what we are doing is the forward pass. This, we are doing the upper part of the nodes. Early start, duration, early finish. And now J follows, and then L also has got some complication because L is preceded by J and K. But K ends at 19, yet it has to wait. You remember the buffer? It has to wait for J to finish so that they supply L. That's why L starts at 24, takes 3 weeks, and ends after 27 weeks. So the end of this project will be after 27 weeks. This is the project completion time. So the forward pass helps us, one, to compute the earliest start and earliest finish times. It helps us to determine the project completion time and identifies the critical path. When you look at this path, there is one with the longest duration. If you add all the durations on each path, because the paths are A, E, H, I, J, L, B, C, D, E, H, I, J, L, B, C, D, F, I, J, L, B, C, D, G, K, and L. These are the paths. Now, one of them has the longest duration, and you should identify it. Then the lower part of this network is where you have the latest start and latest finish. You know, look at, for instance, A, and look at B. If we started A, for instance, after 1 week, A would end on the 7th week, and it would be in a time to supply E, which starts at after 9 weeks. Now, B, that pass for B, before you get to D, you are at C, where you have 7, and then, so D starts at 7 and ends at 9. But supposing we delayed A, we can delay A up even to 3 weeks. If we delayed A 3 weeks, we would still supply, at the end of the 9th week, we would still supply E. And now, so let's go, the backward path, you start it from the end activity, which is L. So we roll the project backwards. Imagine you are using a mat and you wanted to keep the mat. You roll it from end to start. And therefore, the latest, whatever the project must end after 27 weeks. So the latest finish and the earliest finish and the latest finish must be the same. So the lower box is the 27, but it has taken, if it has taken 3 weeks, then it should have started after 24. So the slack, which is the difference between earliest finish and earliest start, or latest finish and latest start, is 0, i.e. 27 minus 27 or 24 minus 24. Then J, certainly for error to have started on 24, after 24 weeks, then J ended at 24 weeks. And then minus duration, they go 22. Here also the slack is 0. But when you look at K, for error to end to start after 24, it means K could have ended at 24. That is the latest finish. When you subtract the duration, which is 4, you get 20. That is the latest start for K. Now the difference between the upper and lower figures is 5. So there is a slack. There is a duration float time, which is 5. In other words, even if you delayed this activity, instead of starting from 15th, it started after 20 weeks, still you'll be in time to supply error. So we can go backwards. Still G derives, G must be ending at 20 for it to supply K at 20, and so its latest start is 14. Now when you do this throughout, it gets some complication. For instance, let's look at a point, let's look at I, and let's look at H and F, which are predecessors to I. H, the latest end for H, the latest finish for H is 16. So is it for F? And when you look at D, the critical point is D now. Let's look at D. D is the predecessor to F, to E, and G. And the F begins at 15. E begins at 9. And G begins at 40. So when does D end? So that it is able to supply to E, to F, and to G, it must be ending at 9. So that it can supply E at 9, supply F at 15, supply 14, G at 14. So we roll the project backwards, and that is the backward pass. This backward pass helps us to determine the earliest and start time, then the latest start and finish times. 1, 2, it helps us to compute slack, and 3, it helps us to identify the critical path, i.e. the path with 0 slack. We have given the critical path 2 definitions, the longest path and also the path with 0 slack.